In some situations, you need to compare quantities. You can use inequalities for situations that involve these relationships: less than or equal to, greater than, and greater than or equal to. A linear inequality is an inequality in two variables whose graph is a region of the coordinate plane bounded by a line. Note this diagram. We have a dashed line, and the right-hand side of that line is shaded. That represents half of the plane, so we can call that a half plane. To determine which half plane to shade, pick a test point that is not on the boundary. Check whether that point satisfies the inequality. If it does, shade the half plane that includes the test point. If not, shade the other half plane. The origin, the point 0, 0, is usually an easy test point as long as it's not on the boundary. Problem 1. Graphing linear inequalities. What is the graph of each inequality? Part A. Y is greater than 3x minus 1. Step 1, we'll graph the boundary line. Y equals, and notice here we're replacing the inequality symbol with an equal sign, but y equals 3x minus 1. We're going to use a dashed boundary line because the inequality is greater than, and the points on the line do not satisfy the inequality. Step 2, choose a test point because we need to figure out which half plane to shade. The test point 0, 0, as mentioned earlier, is usually a pretty easy one to work with. So we'll substitute x equals 0 and y equals 0 into our inequality. Remember, our inequality is y is greater than 3x minus 1. So 0, is that greater than 3 times 0 minus 1? Simplifying, 0 is greater than negative 1. Sure enough, so since 0 is greater than negative 1 is true, we'll shade the half plane that includes our test point, 0, 0. Part B. What about y is greater than or equal to 3x minus 1? The boundary line is once again y equals 3x minus 1, but this time it's solid because the inequality is less than or equal to. Shade the region opposite the region shaded above, which was shaded for greater than, because the inequality is less than or equal to. You can also check the point 0, 0. Substituting 0, 0 into the inequality, we find 0 is less than or equal to negative 1. This time, since 0 is less than or equal to negative 1 is false, the test point 0, 0 is not part of the solution. We can see that here in the graph. 0, 0 is not in the shaded region. You can also inspect inequalities solved for y, such as y is greater than mx plus b, to determine which half plane describes the solution. Since y describes a vertical position, the solution of y is greater than mx plus b will be above the boundary line. The solution of y is less than mx plus b will be below the boundary line. Your turn, part A. What is the graph of the inequality y is greater than or equal to negative 2x plus 1? And part B. What is the graph of the inequality y is less than negative 2x plus 1?